Exercise 10I, arrangements in a circle, question 4. 4 boys and 4 girls are arranged in a circle. How many ways can this be done if there are no restrictions? Seat anybody first. So this is just seat any person. And then how many people are left? 7. So 1 times 7 factorial, which is? 5. Thank you. Part B, if the boys and girls alternate, remember to first seat the first person. So we've 1 for seat any, all right, seat the first person. Now, say if it's a girl, I don't think it matters if it's a girl or a boy, because it's a circle and you could just twist it. So seat the first person. Now, if it was a girl, aren't there only 4 boys that could go there? So 4 other people remain. 4 factorial, no, 4. Wait, so let's say seat first person. Yeah, it is. Seat the first person, then there will be, look, this is what's going to happen. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. There's 4 choices for the next, because if that's a girl, that could be 4 of the boys. Or if that was a boy, that could be 4 of the girls. Now, whatever gender this is, there's only 3 people available for the next spot. And then that one goes with this one, and this one goes with that one. Do you get it? So obviously, so it's going to be 4 factorial times 3 factorial. So we've got 4, 3, 2, 1, and then we've got 3, 2, 1. See, 4, 3, 2, 1. But you'll be able to see that it's going to be 1 times 4 factorial times 3 factorial if you start that working out. Because look, 4, 3, 2, 1, that's your 4 factorial, got it? And there's your 3 factorial underlined. All right, C. What do you get? Now we don't times 2 at the, no times 2 at the end for, okay, sorry, video. She's talking about F. We're up to C. Okay, now, C. If the boys and girls are in distinct groups, so I want 4 boys here. Okay, boys and girls in distinct groups. I might just fold this over, can I? Okay. If the boys and girls are in distinct groups, 4 boys, 4 girls, you've got to seat, because it's a circle, you've got to seat someone first, so you seat that group. So seat one of the groups, seat a group. Doesn't matter if it's boys or girls, it doesn't matter, because I could just rotate the table around. And then let's arrange the boys. So arrange the boys, and then arrange the, whoa. Yeah, I've arranged the 2 groups. They can only sit one way. 4 boys, 4 girls, and if I rotate the table, see, look, 1, 2, 3, 4, 4 boys, girls, a pink. Anyone got blue? Oh, I got pencil. Here are the 4 boys. I can just rotate that table around. It's the same thing. So those boys and girls, the groups of boys and girls, the whole group can only be arranged one way. Seat one group, the other group's automatically seated. If I rotate the table around, they're the same. So seat a group. There's no other group to seat. There's only one spot for them to sit in. You can go times 1. Do you know what I mean? If you're worried, you can go times 1, sit the other group down. There's only one spot left for them. Sit a group, sit the other group, sit the other group. Now, arrange the people within each group. Arrange the boys is 4 factorial, and arrange the girls is also 4 factorial. And what do we get? 24 times 576, and that's correct. I'm sure we've got a little police person checking it all. Now, D. If a particular boy and girl wish to sit together, particular boy and girl wish to sit next to each other. So we can sit that boy and girl down as the first person. Let's sit them down. So 1 times sit the boy and girl. They'll be down first. Do you know why I'm dealing with them first? Because they're the restriction. Now, but can't you arrange them 2 ways? So we arrange the boy and the girl. And how many spots are left on the table? 1, 2, 3, 4, 5. So times 6 factorial. So sit the boy and the girl. They're one group. So the boy and the girl are a group. So they're like you're sitting one person down. See, they're joined. And then you swap them because they can sit the other way and then they'll be next to different people. Arrange the boy and the girl 2 ways and now sit the other 6 people down. Okay? If 2 particular boys don't want to sit next to each other, it's just doing the same as what you just did. That's them sitting together. It'll just be your total minus the answer for part D. See, part D is any 2 people wanting to sit together. They don't have to be a boy and a girl. So, if we've got for part E, 2 boys together is the same as part D, is 1440. So therefore 2 boys apart will be the total, which is 7 factorial, isn't it, from part A? Which is the total minus the 2 boys together. And what was the total from part A? 5040, which was 7 factorial, minus the 2 boys together of 1440, 3,600. Geez, that's a lot of ways to put 8 people at a table.
Are you looking at the
3, that was E, that was 4E. Yep, and F, if one, oh geez. No, I'm just saying because the boy wants to sit between the girls. It's not the question. It's just that the boy, so one boy wants to sit between 2 particular girls. I think we need to sit one girl down first. And then we're going to sit the other girl down, but she's got more than one choice. Okay, so, yeah. So girls, let's sit the first girl down here, right? Now, a second girl, that other girl can go there or there. So, this is what we're going to do. Seat the first girl, that's 1, because she sits anywhere. Then we're going to seat, you can put the boy down next if you want. Do you want to put the boy down? Seat the boy. He's got 2 choices, there or there. That boy. Seat the boy. He's got 2 choices. Let's say the boy sat here. The other girl's only got 1 spot she can sit now. Yeah, I'll do the rest of them in a minute. Seat this first girl. She goes first. Then the boy next to her has 2 possibilities. Then once he's sat down, the next girl's only got 1 spot. So I've sat down 3 people. Sit the other girl. Now there's 5 spots left. I haven't got them all here. Do you understand? Then there's 5 left. Seat. I'm only showing you that arrangement of people there. Pretend it's bent. I'm not worried about. Then there's 5 others. Seat the other 5. So girls, I'm only showing you part of the table here, not the whole thing. Got it? I'm not, all right. Because, look, girls, I should be drawing a round table. I'll do it over here. Where can I do it? 1 sec. Sorry. Oh, geez, that's not good. All right, let's go. Seat the first girl. Here she goes. Got it? Now, I'm going to seat that boy that wants to be next to her, either there or there. So that boy has 2 choices. So seat the girl has 1 choice. Seat this boy, he has 2 choices. Now, that boy will have sat in one of those spots. Let's say he sat there. That's his spot. Well, the other girl has only got one choice. Seat the other girl, one choice. Now we've got 1, 2. So this one wasn't taken because the boy sat there. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So 3 people have sat down. There's 1, 2, 3, 4, 5 seats left. Seat the other 5 people, 5 factorial. See, even though the boy's got 2 choices, he only does sit in one of those spots. Got it? All right. Girls, you can just keep going. Okay. All right. Can I pause this? I'm just going to... Can someone press... I need someone to pause. Actually, let me move this whole thing. There. Let me move that. Okay, question 11. A sports committee consisting of 4 rowers, 3 basketballers, and 2 cricketers sits at a circular table. All right, so how many different arrangements of the committees are possible? So we've got 4 rowers, 3 basketballers, and 2 cricketers, and they're sitting on a circular table. How many different arrangements of the committee are possible if the rowers and the basketballers both sit together in groups? That's okay. All right. I think, let's just make sure we understand what this is saying. So the basketballers are going to be in one group and they sit together in groups. So girls, look, the basketballers, the rowers and the basketballers want to be together. So we've got the 4 rowers together on the table somewhere and we've got the 3 basketballers together on the table somewhere. And it says, so if the rowers and basketballers sit together in groups, but no rower sits next to a basketballer. So doesn't it have to be a cricketer there or there? So that's it. So that's our table. So let's seat someone first. So you can order your rowers and your basketballers first if you want. How would you order your rowers? 4 factorial and 3 factorial. So how many groups are we really sitting at this table? 1, 2, 3, 4. We're sitting, it's like we're sitting 4 people at the table now. So let's just sit someone down. Let's sit, do you want to sit? I'd rather sit the rowers or the basketballers first, otherwise I think we're going to get into a mess if we sit the cricketers. All right, let's sit the rowers. So rowers together, let's just seat. Wait, seat the rowers, but then we can arrange the rowers. Then we're going to arrange the rowers. So seat the rowers, they sit in one place. Remember, the table can rotate. Then we arrange the rowers. So the rowers are done. Now the cricketers, can't one cricketer, aren't there 2 places? So I've got to, so with the cricketers, one cricketer can go there, 2 choices for the next cricketer, and 1 choice for the remaining cricketer. So 2 factorial for the cricketers. Then times 1 spot left for the basketballers, they've got to go in that spot, times arrange, times arrange, geez, that's big, times 3 factorial, which is arrange the who are they? The basketballers, the b-ballers. Arrange the b-ballers. So we've got,
Yeah, it's right.
of course it's right. 1 times 24 times 2 times 6, whatever that equals.
288.
Yo. Okay, you know what? I think question 9's similar, so it's okay. Yeah, so let's just have a break.